an introduction of what's Web3, but I'll try to start from the beginning, from what's Web 1 to Web 2 to Web 3. Web 1 is the traditional 1990, back then, website where it was basically a website. You could only read the website, but you will not be able to write to the website like we do right now, where in such a case, like the website was basically a poster, we can say. That's the first version of Web 1. Then when we come to Web 2, it's now, we are able to read and write. The normal way we use it right now, like WhatsApp and everything. That's now Web 2, but now in Web 2, the data is owned by centralized entities like Google, Meta, Apple, Microsoft, and such. And now when you come to Web 3, you're able to read the data, read and write on the data, and own the data, like WorldCoin, in where, for the guys like WorldCoin Abdi said, you are given incentive for your data to be used in somewhere. Your data is not used for some purposes without your permission. Yeah, that's now Web 3. Web 3, yeah, or Web 3.0, or you can call it also blockchain. Yeah. Okay, and on the Web 3, we have different blockchains. Like we can call it protocols. We have Ethereum, Solana, and so forth. But for today, we'll be covering about Ethereum, which is like the oldest blockchain. It has close to 15 years in existence, and when using coding on Ethereum, you'll have to have some technical knowledge of coding in Web 2, like JavaScript. And now, when you go deeper, it can be harder. But using Web3.js now, you don't have to understand more technical things about Ethereum for a beginner. You can able to interact with the blockchain using Web3.js. Is the oldest JavaScript library that was created on Ethereum in 2015, yeah, close to the same time that it started. That's basically it, and you'll also learn about Solidity. It's a more or less new or old language, you can say. It was mainly made for developers to code easily on the Ethereum blockchain. It's more close to the same as Python or JavaScript. They will be shown a small presentation of how it works and understand everything on the blockchain. Yeah. But basically, that's the introduction of the Ethereum. And Ethereum, one of the blockchains that exist, it's very beginner friendly, developer focused. If you're a developer, the best place you can start is Ethereum. There's other blockchains here, but Solidity is, because it's the programming language for Ethereum, is very easy to start. Pretty much the same as JavaScript. Yeah, small changes, but the syntax is more or less the same. So welcome to the blockchain, and have a good time coding the Ethereum. Let me just finish. You'll just be shown the presentation. For you to code to understand what the blockchain, you'll have to understand what's the blockchain. Blockchain it's called an immutable ledger, we can call it. And also you'll have to learn about something called smart contracts, which are smart contracts, we can say it's the back end of the blockchain, which you'll be writing using Solidity if you use Web3 as a library to interact with already written smart contracts. Yeah, and you'll have to understand something like wallets. Like it's like a unique identifier for you to log into an application using. There's wallets like MetaMask, the most commonly used for development purposes. Yeah, I can say that's it for the introduction. I've said everything. Okay, Santiago can proceed. of this.
Let's just wait while that's text, and then we can start. Hi everyone, can we give a round of applause to Gideon, please?
Thank you so much, Gideon.
So thank you so much for coming today, for taking your time, for being here. I'm really excited to be here today. Let me just put this thing. Okay, I think I put it. Yeah, so before we start, before the screen works, I wanted to ask you a few questions just to understand where are you in terms of development. So just to know if I need to give some step backs when I start the workshop. Because my idea in every workshop that I do is that everyone is able to follow, and then you are not sitting there like fuck, I'm lost. Like, I don't want that. I want you to be able to understand what I'm doing. So don't feel shy to interrupt me and say, sorry, I don't understand that, or can you repeat that, please? That was completely fine. So I wanted to ask, who has used a wallet before here? Or who hasn't? Maybe that's better the question. Who hasn't used a wallet, like in blockchain? Never? Okay, not a lot of people. And have you heard about like Ethereum from before or anything about blockchain? Yeah, who wants to tell me a little bit about what you have here? Or I can choose one randomly. No one wants to share? Okay, so you have the microphone. You can share something. No. Are you shy?
Not shy. I don't have much.
Into blockchain? Nothing? So you haven't heard anything about blockchain?
I've heard, but not much.
Okay. Someone? You? Yeah?
Yeah, so good afternoon. Yes, my name is Mulwa. I'm new to Web3, just learning. There was another session in Zetech where we learned about Solana, and we were able to get introduced to Solana. Then we have Ethereum, and they gave us a platform called calyptus.co, where you get to learn about Ethereum and MetaMask. So it's a site where it takes you step by step from beginning, explains to you about blockchain, about the various wallets, about smart contracts. Yeah, so you can just plug in into that website, and you can be able to learn more. It's an exciting journey, and it's the future.
Amazing. Thank you so much for your contribution. Something else that I want to add, maybe I will just tell you a few things that I know that can be useful to understand like some differences. Who hasn't heard about Bitcoin before? Okay, so everyone is aware of Bitcoin. So yeah, Bitcoin is like the cryptocurrency with like the most capitalization. Capitalization means like people buying it, right? That's the number one. The second one is Ethereum, and I think the third one should be Binance or Solana. The thing is, Bitcoin is a blockchain itself, but you cannot develop applications on Bitcoin. That's like something important to know. Solana is another blockchain, and then you can also build applications in Solana, but then you will need to know Rust, or I think they're already doing some implementations, so you can use your Ethereum skills into Solana. And then if you learn how to build applications in Ethereum, you will be able to build applications in all the Ethereum virtual machine compatible blockchains, which are more than 200, like Ethereum, Arbitrum, Binance Smart Chain, Optimism, even Celo. Are you aware of Celo? Yeah, I think Celo is like everywhere in Kenya too. So yeah, if you learn how to build applications in Ethereum, you will learn how to build applications in Celo, also Base as well, which is really strong here right now. So yeah, all these skills are transferable to any Ethereum virtual machine blockchain. Yeah, that's kind of like a little intro. I don't know if I should say. Do you have any other questions? Something that you would like to know? Even if I don't prepare that, I'm sure that I will be able to give you any answer. Something that you want to know about blockchain while we fix this. No, any questions? You shy? Yeah. Thank you.
Hi,
Hi everyone. My question
Right.
is, like, for example, I've built on ICP and I've never gotten started with Ethereum. So my question is, how easy is it to transition from one blockchain to another?
Oof, that's a good question. And the thing is, I never use ICP. So can you tell me what? Okay, now I have a question for you. What did you use to build an ICP? Maybe tell us a little bit about what did you use, how was your experience, and yeah, we can learn about ICP too.
Okay, ICP, like, you see the way people are saying about Ethereum, ICP is a blockchain
Yeah.
itself. Okay, my experience with ICP, it's quite easy because it has a language in itself that helps developers develop the smart contracts. It uses Motoko.
Motoko.
Yeah, Motoko. And it's very compatible with like any other language in the front end. You can use any other language. So my experience was good with ICP, but I want to know about Ethereum.
And what did you build in ICP?
Actually, it was a hackathon I attended. It was a decentralized app. I built a decentralized loyalty point exchange system.
Only with Motoko?
Yeah, the backend, the smart contract
Okay.
was in Motoko.
Oh, okay. And then the front end?
The front end was in React.
React, okay, JavaScript. Okay, amazing. Thank you so much for your contribution. And then I have another question. Do you know if Motoko can be used somewhere else or it's only for ICP? Only for ICP, okay. So I will say that at least the theory and the structure will be the same in Ethereum, but then instead of Motoko, we will use Solidity. But yeah, we will also have like a React application, and then the React will talk to the smart contract, which is written in Solidity, and that's what we are going to do today. Yeah, just need to wait a little bit, but yeah, that's the only difference. Motoko will be the Solidity in Ethereum, and a little advantage is that then Solidity, you can use it in a lot of different chains. The blockchain has different layers. I don't know all of them, but I know that there is settlement layer, execution layer, and the most important that I always focus on is the application layer. So in the application layer is the layer that we use to build the apps on that blockchain. And then any blockchain that has Ethereum virtual machine in the application layer, you will use always Solidity and then JavaScript to interact with the blockchain. But then that's why there are a lot of blockchains right now in Solana as well, that they are using the settlement layer and the execution layer of, let's say, Solana or different things. But then they put the Ethereum virtual machine in the application layer, and then you can, let's say, use the best capabilities of Solana here while building applications with the same skills of Ethereum in the application layer. So that's something like a little bit more advanced. I don't even know about the settlement and the execution layer. That's like too much infrastructure for me. But yeah, I think I kind of answered your question. And instead of Motoko will be Solidity. Any other questions? Something that you want to learn before we connect the computer? I see. Thank you. Careful with that.
So hi.
Hi.
Mine is not actually a question, but some clarification.
Perfect.
I've been seeing a lot of Web3 sessions, but I've been very reluctant to attend them because I kind of didn't have that idea of what Web3 is, but I believe this session will be like an eye-opener. So the question is, the comparison that Gideon was giving on the difference between Web 2 and Web 3, or the transition between Web 2 and Web 3, he mentioned something about data, that for Web 3 applications, they live on servers owned by some companies,
Yeah.
of which you don't own that data. Different to Web 3 where we own the data. So that's the point that I get confusion with. Because I believe for anything to be accessed on the internet, it has to live somewhere on a server, right?
Okay. Yeah, let me then tell you some things and then we can have a conversation. Yeah, so the main difference is that we have decentralized servers. I don't know, let's say Facebook. I'm sure they have servers in, let's say, Amsterdam, the US, and somewhere in Africa, right? But then here with the data, those servers will be nodes. And the nodes are just computers that are validating the network. So you can be a node with this computer. You just need right now to stake 32 ETH. Before Ethereum was proof of work. Proof of work kind of requires you to have like a really strong machine to be able to validate the transaction and to make sure that everything is kind of validated, that is kind of working properly. But then I think 1 or 2 years ago, they changed it to proof of stake. So proof of stake, for you to be a validator, now you don't need a super machine, now you need money. So now you need 32 ETH because that's cheaper for the network, more environmental friendly. But then the data lives in these nodes. If you want to run, there are different types of nodes. One is like a full node, where you will store all the data of all the information since it was created like 10 years ago. And then the other nodes are just like the validators that will validate the network. So you don't need to store like this. I don't know if it's like 300 something gigabytes of data, but then the data will live there and anyone can have that data. So I think that's, to answer the question, anyone can own the data because we can be validators because it's a public blockchain. If we go to a private blockchain, that will be kind of similar to a Web2 application, because a private blockchain, for you to have these nodes, you need permission from the blockchain itself. So that's really similar to a normal Web2 application. But then in this case, anyone can validate, anyone can own the data. So that's why, let's call it this decentralized and distribute. I don't know if that answers your question. You want to ask more or ask me again?
Maybe the question should be, assuming I'm using Web3.js to build the app,
Yeah.
decentralized application, I will still use the very same servers that are provided by the so-called players in Web2 that own the data, to still have my data there so that it can be accessible by my end users.
Which servers are you talking about? Because you don't need to talk to any server.
Assuming, maybe it's me who's getting Web3 wrong. I'm assuming I'm building whatever I'm building on the blockchain with my machine, my computer.
Yeah.
Right? For it to be accessed by other users, because I can't be building for myself.
Yeah.
For it to be accessed by other users, where is whatever I'm building? I don't know whether I'm calling the source code or anything. Where should it live?
That's a good question now. Okay, so that's a really good point. Now you open my eyes a little bit. Yeah, so let's say that, Vercel, like then if you deploy your DApp on Vercel, we are still like using Vercel, which is a Web2 with servers and everything, to be able to show our app to the users. And then your point is, where is like the Web3? If anyway, we need Vercel, right? But then there is another thing that is called IPFS. Have you heard about IPFS? So IPFS is Interplanetary File System that allows you to deploy things and no one is the owner of that. That's like another blockchain. There's also millions of computers around the world having the data, and that will never be like deleted from there. Once you deploy something to IPFS, that will be there. So if you want to be super Web3, super decentralized, I think that's the way. You deploy your front end or your dApp, but then you cannot have servers in that case. You will only have like a client which will interact with the blockchain, with the smart contracts. So you deploy your front end to IPFS, and that front end will be there forever. Then you deploy the smart contract in the blockchain, that will also be there forever, and then they can interact with each other. So your users will go to IPFS front end and then interact with the smart contracts. And then in that case, we don't have any servers, we don't have any Web2 involved. And that's the pure blockchain maximalist, I would say. That answered the question, that part of the IPFS? Perfect. Okay, let me go to Moses.
Okay, so I just wanted to add on that.
Perfect.
Like ICP, like everything is done on centralized. The front end, the smart contracts that deploy to the ICP. So maybe he may also considering that, whereby the front end is deployed to the blockchain itself and also the smart contract.
Amazing, thank you, Moses. Everything is decentralized in ICP. Okay, that's also really interesting. Yeah, I never explored ICP myself, but I will play around with Motoko. Any other questions? Something else that you would like to know? No one? Everything is clear? about, I don't know, crypto, anything, tokens, Ethereum, blockchain. But I don't know if we should just wait until the screen is on. And yeah, then if you have it, oh, okay, well, I was going to sit. Thank you. Thank you for asking. I appreciate that.
I'm Prudence. Can you explain the security aspect of blockchain? How do you go about it?
The security aspect, what, sorry? And what can be... Okay, maybe, yeah, I can have a quick answer for that. So for the security aspect, do you know about wallets? No? Okay, so maybe that can be the security, I think. So there are different things that we can talk about security. The first thing, maybe let's just start with the wallets, with the concept of wallets. Normally a wallet, you always need a wallet to interact with the blockchain. I think in ICP too, you also need a wallet, right? Then a wallet will have two properties, a private key and an address. So this address is for people to send you, let's say, money, right? And then the private key is like the password to access to that wallet. So the private key is something that you can never lose, because then if you lose your private key, you will not have access to that wallet. And then, I forgot this number, but then for someone to guess your private key, they can have the best computer in the world or something like that, but then they will take years, I don't know, millions of years to be able to randomly access that private key. When I was learning about blockchain, I learned that there are more, like even stars in the universe and sand in the world and everything. There are even more private keys, sorry. So it's impossible to literally just try to get access to a private key. You can generate random private keys, but you will never get one. You will never get, like, let's say my wallet or her wallet or whatever. So that's the first thing. If you lose your private key, you can lose like access to your funds and everything. That's I would say like a hard part of blockchain itself, because that's not really user friendly. That's why there are like a lot of different things that are being implemented to improve this. Or if you show your private key to someone else here, then that someone will have access to your funds and then they will drain your wallet. So that's the first thing. Then the second thing with the smart contracts, when you deploy an application, if you deploy a smart contract, normally if you have a bug or something, then someone else can attack your smart contract and then they can, let's say, drain their smart contract or do some things like that. So that's why it's always really good to do audits or things like that to have like a really secure smart contract. Because normally once you deploy the smart contract, you cannot change the code. That smart contract will be there forever, except if you deploy a different type of a smart contract that is called proxy, but that's a little bit more advanced. But yeah, normally those are the two things that you need to know. And then the blockchain itself is secure. Let's say if you have a smart contract, that's my plan of today. We are going to write a smart contract that can receive donations, right? And then this smart contract will only allow myself to withdraw those donations. And that's the code that we are going to write, and that will happen. So if you try to withdraw the funds from my smart contract, that will not work. So in that term, when you write good code, it will work. It will never fail if you write good code. But then the issue is to write a good code. Yeah, I don't know if is that clear? Any other questions? Okay, we're getting more interactive. I like that.
Yeah, I think back to what you mentioned, given the utility of smart contracts, and how do you ensure the approach is applicable contracts?
Yeah.
And if you're using now the proxy patterns, what are the risks of proxy patterns?
That's also a good question, because I will say, like, I like the immutability part. So I like to interact with something that they are not using proxies, because you know that the smart contract is there and the code will never change. But then for the proxies, what you need to do is to basically deploy two smart contracts. One that is the implementation contract, and then the other one, I don't remember the name, let's call it the router. So you interact with the router, and then the router is pointing to the implementation, and then it interacts with that, and then comes back. And then when you upgrade the smart contract, you are upgrading the implementation contract. So now the router is pointing to this other one. So now when you interact with the router, you're not interacting with this one, you are interacting with this one. But then if you're interacting with a DeFi protocol, they have this, but then in the second implementation, they implement a malicious code, then it's not as good, right? But then if you interact always with this one and they don't have the proxy pattern, I would say that's more Web3, right? But then that also will not allow you to have updates or things like that. That answers your question? Amazing. Any other questions?
Hello.
Hi.
My name is Fidel, and I had a concern. We say that the major problem in the Ethereum network is scalability, but I've never really understood how that becomes a problem, or in what aspect is it a problem. So yeah, I think I would love to understand more how or what exactly is
The scalability
of Ethereum and how solutions like layer 2s come to solve that problem. Yeah.
Perfect. Thank you, Fidel. Nice to see you again. When I get this type of questions, I'm really lucky that I'm doing this workshop today, because 1 year ago, I wouldn't be able to answer that question. It's a little bit maybe advanced. The blockchains are always having an issue that is called the trilemma issue, something like that they are trying to be secure, scalable, and private. Yeah, those three. But then Ethereum can never have the three of them, so that's why the layer 2s exist there. The issue with the scalability is that, let me try to frame the idea. Always when we interact with the blockchain, we need to pay gas, right? We need to pay some gas fees. The more transactions that we are sending to the blockchain right now, the more expensive it is, because every block can only have, let's call it 30 million of gas. The unit is called GWay, but then every block can only have 30 million. And let's say that sending one transaction will cost 1 million. It costs way less, but let's make it easier. So one block can only have 30 million of gas, and then I'm sending him money, and then that transaction costs 1 million. And then if I send 30 transactions, I'm already covering the 30 millions of one block. One block is kind of created every 12 seconds in Ethereum. So for these 12 seconds, I already took one block. But then what if all of you are trying to also send transactions? So in that case, the one that pays more money will get the transactions executed. And that's why it's not scalable, because then, okay, you pay more, but then someone else in France will pay more, and then someone else will pay more. And at the end, for sending a transaction, it will be really expensive. And that's why it's not scalable, because then we don't really have like unlimited power to do whatever we want in these 12 seconds of one block, and we only have the 30 million way. I don't know if that's clear, that part. Okay, and then for the layer 2s, wait, let me just, can we get water maybe? Yeah, I'm a little bit thirsty. Thank you, Abdi. And then for the layer 2s, what happened with the layer 2s is that it's like another blockchain. Layer 2s are other blockchain, but then what happened is that they have their own system. So let's say the CK Sync. I don't really know how CK Sync works specifically, but then let's say that CK Sync has 1 trillion of gas. So that means that you can do a lot more things in CK Sync. And then they are going to batch all these transactions, confirm the transactions, and then they will register these transactions in Ethereum. So that's why the main layer is Ethereum, but then they are doing their things in the layer 2. They register the transaction, let's say faster, better, or more quantity, whatever, and then they register that in Ethereum to say like, hey, this happened in my layer 2. So that's why the layer 2s, they have a different system, but then they also relay they also relay in Ethereum. So Ethereum is a layer 1, then we also have other layer 2s, and it can be more layer 1s with more layer 2s on top. But yeah, in this case, we have like Ethereum with these other layer 2s like Arbitrum, CK Sync, Optimism, etc. I don't know if that answered your question. Amazing. Any other question? Yeah.
So on the security aspect of it, this is on securing the DeFi. So
On what, sorry?
Securing DeFi.
Okay.
So it's prone like issues like flash loan. So how do you ensure that it's secure without actually introducing centralization?
Okay, what is secure?
No, I mean, how do you actually ensure DeFi smart contracts are kind of secure as a developer when you're building that? Just to be, it's prone to attacks as well. Web3 is safe, but
Oh,
yeah.
okay. Okay, I got something. Yeah. Yeah, that's true. The thing with the flash loans is that that's a little bit more advanced, but the flash loans is that you can get a loan in one protocol. So let's say that I borrow $1 million, but then before the block ends, I pay again that block, that money, that loan, right? So I borrow $1 million from Uniswap, I do something, and then I pay that back before the block ends. So that's kind of something really fast. Like I pay, I do something, I repay again. And that's not really, let's say, insecure, because at the end you are not doing something bad with that. But you are just playing with protocols. Let's say that in protocol A, Ethereum costs $1, and in protocol 2, Ethereum costs $1.1. So what I'm going to do is borrow money here to buy here, and then repay here again. That's like a little bit more DeFi advanced, but that's not really insecure. At the end of the day, a flash loan is just, you can do that in real life. Like you can borrow money from me to pay her something, and then ask her for money to pay me back or something, and at the end of the day, everyone will be in zeros. So the flash loans are not really insecure. But yeah, it's just about taking advantage of different protocols in DeFi. That would be more like a way of seeing that. Yeah, I don't know if any other one has more questions. Yeah. Okay, now this is a debate of blockchain.
A concern again, not actually a question. Is money and funds a way to explain blockchain better, or it's blockchain all about money?
Oof.
Because as you converse around Web3, it's about paying, taking loans, this, that. So is it that blockchain is more of money? Because with me, I understand Ethereum as a cryptocurrency coin.
Yeah. Okay, now we are having a philosophy class now about money and blockchain. That's a really good question. You know why? Because that's true. Ethereum is a cryptocurrency, but then the cryptocurrency itself that you use to pay for the gas. That's why you need Ethereum, because you need to pay. If I'm sending him $1 million, I need to pay that transaction with Ethereum to pay the network, and that's how the network survive as well. And then what he was saying was about DeFi. So DeFi is only one use case of blockchain, but there can be a lot more use cases that are not about money. Like, for example, you can do, that's more about real implementations, like securing data of people, but then a user doesn't need to have like Ethereum. Ethereum is only used to pay for the gas fees, but you don't really need to think about money. But I think DeFi is one of the best use cases, money. Because let me tell you something about DeFi and liquidity pools, which can be a little bit interesting. You have Kenyan shillings, and then you want to buy dollars, right? So you need to go to someone that has dollars to be able to give you dollars, and then you can exchange, right? But then in DeFi, there is something called liquidity pools, where a lot of people can put Kenyan shillings and can put dollars. Okay, we're getting closer. So we can put in the liquidity pool dollars and shillings. And then every time that you want to do the swap of USD and Kenyan shillings, you come to the liquidity pool, you get money, you take the money, and then you pay. And then the people that put money in the liquidity pool are getting a fee. You know what I mean with that? Or I can re-explain that again. You got the liquidity pool concept? Perfect. So what happened with the liquidity pools is that that's public. Anyone can put money in the liquidity pool, and then you will also make money in the liquidity pool. So that's why DeFi, the decentralized finance, is one of the best use cases of blockchain, because then that's people borrowing to people, and we are just like people playing with people around without the need of maybe other people or other. I don't really like to talk against governments or whatever. I think that we need governments, But yeah, that's just giving us more opportunities to interact with each other and the community itself. I don't know if you got that part of the DeFi. But then there can be games. I don't really like games. I am not a gamer. But then in blockchain, you can also play games. And that's not about money. That's like another use case. And yeah. But crypto is the best, not the best, but the most well-known use case of blockchain. That's a reality. Yeah.
So you can just jump.
Oh, okay. Yeah.
So I had a friend some 2 years back. He ordered a very heavy machine.
A what? Sorry.
Machine.
Computer. Yeah.
With a lot of graphics. Then he ordered some extra parts. The idea was he was trying to do something on the blockchain. So maybe you can explain what he was trying to do. He was like, this machine has to be really powerful.
Yeah, I think. Oh, it turned. I think he was trying to maybe mine. So there are these two type of consensus algorithms in different blockchains. Bitcoin is using proof of work. That's what I said before. And then in proof of work, I don't exactly recall that, but you need to make a guess in proof of work when you are a miner. And that guess is to find a random number among trillions of numbers, something like that. And then when you guess that number, you can validate a block. And then when you validate a block in Bitcoin, you get some rewards. But then to guess that number, you need to run, let's say, a lot of loops, trillions until you get that number. So that's why you need like a huge machine to be able to validate with proof of work. So you need these huge machines that you see even some people like in China, they have factories with huge machines to validate Bitcoin. And then Ethereum was like that too. But then that's why they changed to proof of stake. And now you can just use your computer, but then you need 32 ETH, 32 Ethereum to be a validator. Now you don't need these huge machines. And there are different types of blockchains with different types of consensus algorithms. But yeah, in this case, Ethereum proof of stake, Bitcoin proof of work. And I don't know, there are more, but I don't really remember the other ones. Those are like the two main ones. Someone knows any other proof of something? Yeah, I think that's even like a little bit more advanced. But yeah, you know that you get the answer? Perfect. Any other questions? I think we are getting closer with the computer. Oh, that one is working. Mine is not working. Okay, that's fine. Yeah. Any other questions?
Okay, I wanted to ask, what is the difference? Is there a difference between blockchain and, let's say, Ethereum?
And Ethereum.
Yeah, or Bitcoin?
Yeah. So blockchain is the technology. Blockchain itself is just a database. And then Ethereum is a cryptocurrency that is used between this database. But then there can be a lot of different blockchains. So Bitcoin is one blockchain, Ethereum is one blockchain, Binance Smart Chain is one blockchain. And for you to play around in that blockchain, to play with DeFi or to play video games or whatever in the blockchain, you will need the cryptocurrency of that blockchain to pay for the gas fees. So in Bitcoin, you pay the gas fees with Bitcoin. In Ethereum, you pay the gas fees with Ethereum. In Solana, you pay the gas fees with Solana. So that's why they also have one cryptocurrency, or let's call it token, but the right word is cryptocurrency, to be able to interact with every network. Because you need the cryptocurrency of that network to play around with this network. And that's an issue that happens a lot. Let's say I have a Polygon wallet, right? And then I won a hackathon, $1,000. So then the sponsor sent me the $1,000 in Polygon. But then I don't have Matic, that is the cryptocurrency of Polygon, to pay for the gas fees. So then I need to go somewhere, let's say to Binance, buy Matic, transfer Matic to this blockchain to be able to pay for the gas fees to do something with those $1,000, because the $1,000 are in dollars, not in Matic. So that's an issue that happens a lot with blockchain, that you always need the native cryptocurrency of the blockchain to pay for the gas fees. And that's the difference of the different blockchains and the token itself that is used to pay for the fees. You got the answer? Perfect. Any other questions? Hey, this guy is really active. I like you. Thank you.
Just one last one.
Yeah, no, you can ask a lot.
every speaker speaks about AI. Now, in terms of how do you think or how do you see the use of AI in blockchain? What are the opportunities for developers? And also now, how will you now use the AI models in a decentralized way to actually verify the models and create, transparency, trustworthiness? What do you think about that?
Oof, that's a good question too. Uh, I think that's an issue right now because in blockchain you cannot really run a lot of things. So you cannot run a AI model agent inside Ethereum because that will cost a lot for you if you have logic in a smart contract. So have you heard about oracles? Yeah. So for the people that maybe haven't heard about oracles, oracles are also in a decentralized way. Let's say computation that can happen outside of the blockchain, but then you put this data into the blockchain. So there is a really good use case of one, let's say, partner that we are working with that is called Aura Oracles. And what they do is that they have oracles on chain. So you can call a smart contract for them, and then they off chain, they run their things. Let's say that you ask a prompt, like what is the capital of Nigeria? And then their smart contract is calling the oracles that they have. They compute the information and then they retrieve the information on chain. And that's like a cheaper way to be able to interact with AI. But there is not really AI inside the blockchain. But when I was in ETHCC in Belgium, like 2 months ago, there was I think it's called Galadriel. There is a layer 1 that they are implementing AI inside their network. I don't really know how that works, but then maybe they are already implementing something that you can create your AI models or something like that inside the blockchain itself.
So in terms of opportunities as well, so as Web 2, how it is now. So how do you tell now the developers, the people that are learning Web 3, in terms of what are the opportunities for them as developers?
Okay. So what are the opportunities for developers in kind of AI and Web3? I will say that that's basically more about the programming language. Because let's say if you know JavaScript, with JavaScript you can do whatever, even with Python, some things as well. But I think JavaScript is the king in terms of programming language. So if I know JavaScript, I can build applications in blockchain, but then I can also go to ChatGPT and create an application using OpenAI, right? So it's more about if you know JavaScript, and then you can try to find a really good use case or how I can mix blockchain with AI. That will be a good opportunity. But right now, there are just people trying to get AI into blockchain, but that's not really something that has happened yet. But that's just developing for now. Yeah, I think as long as you know JavaScript and you are just a good learner and just try to find use cases and problems, you will find the opportunities. But yeah, if I recommend something, JavaScript. That's what I will just say. Yeah. Okay. Any other questions before we start? Now we'll start with some coding. That would be better.
Hello. For me, it's just like I'll take you back since this is my first session about blockchain and editing. So I want to understand what is Ethereum, what it does, and also what language it's coded in, and also the difference between Bitcoin and Ethereum, and which is better between the Bitcoin and Ethereum. Yeah, I'm just saying that.
Okay, I'm getting a lot of questions that I never got in my life today. That's really good. So I will say that the main difference of Bitcoin and Ethereum is that you cannot build applications on Bitcoin. That's the first thing. Bitcoin is only a blockchain that allows you to transfer Bitcoin. I mean, right now they're trying to build different layer 2s on top of Bitcoin, so you can build applications on Bitcoin. But then Bitcoin itself only allows you to send Bitcoin. That's the use case of Bitcoin that was created in 2009 and 2009. And that's the only thing. Then Ethereum was created like in around 2017, and then allows you to use the capabilities of blockchain to create applications on top of that. So that's the main difference, that you can build applications in Ethereum, you cannot in Bitcoin. But then if you have a lot of money and you want to save money, I will get the money in Bitcoin, because Bitcoin at this point is more like reliable and trustworthy around the world as how is that called? I forgot the term of that. As a sense of like saving money. Bitcoin is stronger at that, more like as a currency now instead of a technology. I would say it's more in that way. They also use different technologies like the consensus algorithm. So Bitcoin, you need these huge machines to validate the network. In Ethereum, you need money to validate the network. And then in Ethereum, I would say that right now a lot of issues, not issues, but people are just trying to find more use cases of how we can leverage this technology to build applications, right? Because a lot of people just try to play around with blockchain and just build applications that you can just do that in Web 2 and it will be better or cheaper. So that's a really good question about the use cases. And then it's written in Golang. There are different implementations of Ethereum as well, and also different consensus clients. But the main thing, if you know Golang, you can be an Ethereum contributor and play around with Ethereum. So that's also another thing. But then to build on Ethereum, you need Solidity. Those are like two different things. Yeah. Any other questions before we start? Hey, the ICP girl.
My question is, can you expound a little bit about NFTs?
Ooh. Okay, but then let me then come to my computer to show you some things about NFTs. Oh, isn't that one? Oh, this one never worked. Okay. Let me try to see if I can do something. Because I just wanted to show you what is the NFT. So NFTs are basically smart contracts with some functions. Where is Abdi? Oh, he left, trying to put my computer. Oh, okay. Oh, okay, this works now. Let's see if I can show you the functions of the NFTs. Where are they? Can I find this? Okay, so basically an NFT is a smart contract with a bunch of functions, but then these functions will allow you to interact with this contract. Maybe before we talk about NFT, let's talk about tokens, because that's a little bit easier, but then you can get the same idea. So these smart contracts will just store an address and then the balance of that address. So let's say my address has one token, or your address has another token. And that's basically the functionality of a token. Then you can do different things, like you will see the different functions to transfer or just to get the balance of my account and things like that. But then a token, a ERC20, is just a contract that will allow you to own tokens. And the functionality of the smart contract will just have, that's called a mapping. You know what is a mapping? We'll just map your address with a balance. That's basically a ERC20. And then in an NFT, which is a ERC721, the only difference is that we are adding more properties to that token. And then that token will have a name. It can have other different things. And also another difference is that it's not, I forgot that word, that is not divisible. It's fungible. So a token can be, you can have 1 million, but then if you have one NFT, you cannot really divide that NFT into little pieces. You have only like one. Now there are different smart contracts that allows you to do that, but that would be the main difference. It's just a contract with a mapping in simple words that will store a wallet with a balance. And then with the NFTs, it's the same, but then this contract is also pointing to an image or a video or audio, whatever, and then that will store that information. And yeah, I don't know, I would not go really deep into the implementation of the NFTs. But yeah, do you have any other questions with the NFTs? Is that like a high level? Okay. The thing is, I will need my computer to code. Okay, I think I have this. Sorry? 2 minutes? Oh, Google Meet. Oh, okay. Okay, when? Now? Oh, okay. Okay, I think we will start soon. Yeah, we can. We are using Google Meet, or what we are going to do. The thing is, I will need to code from my computer. Because yeah, it can take me years to to code in a new computer. Yeah, so maybe let's just have like a Google Meet. Yeah, maybe another workshop that we can do, if you guys like really are into this, it can be to create a ERC20 or an NFT. I think creating a ERC20 is better, is because that can help you to get a first understanding of tokens, and then once you create a ERC20, then you can create a ERC721. But yeah, you can ask Abdi, hey Abdi, bring Santiago to build tokens so we can build smart contracts of ERC20s. That would be a nice workshop. I will have that prepared too. Okay, have this soon. Yeah. Work? Oh yeah. Who from here don't know JavaScript? Everyone knows JavaScript. Okay, so you can stay here then. That's good. We just need JavaScript for today. Okay. Oh yeah, I think that will work. I think you can double click or something and it will be full screen. I don't know. Okay. Okay, I think that's good. Can you all see the screen? Yeah? Okay, can you still hear me properly? Yeah? Perfect. Okay, so this is what we are going to need for today. We are going to need any like a code. Yeah, the thing is I will need to code, and then but they can still hear me. Like I think it's fine. If I don't use the microphone, can you still hear me there? The girls in the last row, can you still hear me? Yeah. Okay, I think they will be fine. Okay, perfect. Who has never used MetaMask? Okay, so that's the only thing that we will need for today. You can just go and then you can type MetaMask in Google and install that. That's a Chrome extension or also a Brave, depending on the or Firefox. Oh, it's not sharing everything. Why not? I'm sharing my whole screen. Oh yeah. Yeah, so basically I just type MetaMask in Google, then you can see here. Then you can install the extension. In this case, I'm using Chrome. And then I have MetaMask here. Then when you have MetaMask, you can create an account. Basically for the accounts, you will see the different accounts that you have here. In this case, normally I have an account for every workshop that I give. So I have different ones here. And some of them, they have balance. This is like testnet balance. Oh, great. Yeah, that's a little bit blurry there. And then here in the left, you can change the network. The network that we are going to use today is called Sepolia. That's like the Ethereum testnet. So I'm going to switch. So yeah, for now, just download MetaMask. And another thing that you will need is testnet tokens, because remember that we always need tokens, in this case, Sepolia tokens, to interact with the blockchain. I put the link here. I will share the slides on my Twitter also of Google faucet. So in this faucet, what you do is that you come to MetaMask. You can copy your address here. You will have an address. You paste it here, and then they will send you 0.05. Oh, why is not sharing this? I don't know why. I'm sharing my whole screen. That's weird. And it was sharing everything. Let's see if that works now. Yeah, it's not changing. Oh, I don't know what to do. What if we try Zoom, Abdi, maybe? But I'm sharing my whole screen, and it's not. Okay, now it changed. Okay, yeah. So we will have MetaMask here in the top right. Okay, now it's working. Yeah, and then under the name of your address of your wallet, these are like the different wallets that I have. You will see the address of your wallet here. And then if you want to see the private key, which is like the password to access to this address, you can come to account details, show private key. Then you put a password that is your MetaMask password. You confirm. You click in hold to reveal private key. And then this is the private key of this wallet. So remember that we will have always these accounts. An account will be a private key and a wallet. That's the only thing that we will need to know. Never share your private key. This is only like a testnet account that I have with testnet tokens. And then when you have this address, you can go to this, see if it's changing, to this Google Cloud Web3, and it's a faucet where you can get testnet tokens. So you just put your wallet address here, you click in receive Sepolia, and then they will send you 0.05 Sepolia testnet tokens. So that's like the main thing. Okay, here is the link. I will share this on my Twitter. Santiago DevRel is basically here. This is not changing the screen either. Wait, every time that I change the screen, I need to share again. This is being annoying. Jesus. Yeah, so this is my Twitter, and now let's start with this. Abdi, maybe can we use Zoom? Abdi, can we use Zoom? Because when I change the screens, this is not, it's not showing everything. Yeah? I'm sharing the whole display. Yeah. Look. And I'm choosing this one. That's the whole display, yeah. That's share. It's called sharing, yeah. Yeah, I don't know. That when I changed one tab from another one, it's not showing there. And I'm sharing the whole thing, the whole screen, yeah.
I'm thinking like it's more.
Okay, but then.
And the terminal. Yeah,
okay, now it's working. But then in 1 minute it will not work. I can do it now. Let's see. Yeah, maybe to do something a little bit more practical, what I will do is to start with a React application. So npx create React app. Okay, it's working for now. That I will call Zetech. Then it will create this React app. And then another new tool that you will learn today, it's called Remix. Who hasn't used Remix before? Okay, perfect. So you will learn this new tool today. You can go to remix.ethereum.org. And basically, this tool allows you to write and test smart contracts And then when you come here, you will see something like this with a lot of different folders that you don't need to care about. I will actually create a blank one so you can understand everything. Workspace, create blank, Zetech. Okay, so this is Remix. What we will do is that here we have the different files that we create. Yeah. So I will create a new file. Called Zetech.sol. Let's see. Okay. And then this will be the smart contract that we are going to write for today. So in the slides, I already have slide by slide what we are going to write in a really easy way. Let's see if it's sharing. Wow. Okay, now for Abdi, where is Abdi? Abdi. Oh no, now it changed. It's fine. Okay, so this is the step by step that we are going to do. First, we are going to write the contract. Then we are going to deploy the smart contract in a Remix virtual machine. And then we are going to deploy this in Sepolia. So let's just kind of start really quick with this. This is the structure of a smart contract. We will always need to have a license. In this case, I will just put this random license, MIT. So let's start writing this smart contract. SPDX. Yeah, showing there. License, identifier, things like that. Yeah. MIT. I always use this license randomly. That would be fine for today. Oof, but you cannot really see the characters, right? It's really blurry, right? That's an issue. I don't know if Zoom will be on here. Okay, looks a little bit better. Okay, that's just a little bit slow. Okay, yeah. So SPDX-license-identifier. Then we have the MIT. Then the second thing will be the Solidity compiler version that we are going to use. In this case, I'm going to use 0.8.0. And then we create an object that will be the contract object where we are going to implement all the different things. So I'm just going to write, I will go back to Remix. Just zoom in here. Okay. So Pragma Solidity 0.8.0. Okay, so the license, the compiler version, then the contract object that I'm going to call Zetech. Okay, it's loading now. Then we will have a lot of different properties and functions. The properties here will be called state variables. And then we will have functions. Yeah, which will be the constructor. Okay, and here is a really interesting concept that you need to understand. That is the difference between writing functions and reading functions. So when you have in a smart contract reading functions, this will only like fetch data from the smart contract, so will only retrieve data. Let's say that you are calling a token, and a reading function will be to know what is my balance. That's a reading function. But then a writing function will be for me to send you one token, because we are changing the state of the smart contract, and we are changing this mapping of my balance and the balance of the other person. So those are the only two types of functions that the smart contract has. Reading functions are free, because you are not changing any state, and writing functions, you need Ethereum or any token to pay for the fees. So that's the basic structure of a smart contract. And now we are going to implement this contract that I call it Buy Me a Coffee. Who from here don't know the concept of Buy Me a Coffee? Everyone knows what is a Buy Me a Coffee? So Buy Me a Coffee is like something used in Web3 to send me donations. So we'll just write a smart contract that this buy me a coffee is just donate me money, literally. So we're just going to get this smart contract to receive donations, and that only the creator of a smart contract, in this case me or you or the person that created the contract, will be able to withdraw the money from this contract. Like no one else will be able to get the money out of here. Yeah, so I have here the different functions that we will need to implement. The first one will be the constructor. Who don't know what is a constructor? Everyone knows what is a constructor? Perfect. So yeah, the constructor will be a function that can be called only when you deploy the contract. So only one time. This function is executed when you deploy, and that's it. And then when we use this constructor, we are going to set the owner of the smart contract. So the owner of the contract can be never changed. So if I deploy the contract of the donations and I say I am the owner, then I will be the owner of this contract forever, and only the owner will be able to withdraw the money. That's why we are going to use the constructor. Or you can also implement a function that can change the owner of the contract. But in this case, we are just going to have it in the constructor. Then we are going to have a reading function that is called get current balance. Yeah. This get current balance will just retrieve the current balance of the smart contract. So let's say we receive $1,000 in donations. So we can call this function to tell us what is the current balance of the smart contract. Then we are going to have the withdraw function that is a writing function that will allow us to withdraw the money that we receive in the contract. We are going to have this donate function that will allow any external user to call this function and donate money to the smart contract. And this receive function is something that needs to be implemented by default if we want that our smart contract can receive money, in this case, Ether. So now let's start implementing the contract. I have in the slides function by function, so you will be able to follow as well after the workshop. So the first thing that we need to add are the state variables. In this case, oh, it's loading. In this case, the only state variable that we will have is the owner, that is my address, right? Because we will call that owner later to have some required functionalities and some kind of, let's say, if. So the first thing that I'm going to do is just to write the address owner, and here we are going to store my address. But you can also create different types of variables, like uints, strings that are not really recommended, also bytes, etc. But for this one, only an address. Does anyone has any questions so far with this? I will stop a lot to ask if you have questions to see if you are lost. Anyone has any questions with this implementation so far? Yeah? Yeah, what was the question?
I can see the address
of the owner, yeah.
How about the recipient?
The recipient will be the smart contract. So yeah, okay, that's a good question. So we will have, let's say, two addresses here. The owner will be me, but then the one that will receive the money is not me. Like, you will not send money to me. You will send money to my smart contract. And then the smart contract is handling this logic of me withdrawing and you donating. Or you can directly send the money to me as well. But then that will be without the smart contract. And for today, the idea is to have a smart contract and also have a dApp on that. And then the smart contract will have an address too. But then that address, we will know it only when we deploy the contract to the Sepolia testnet. Is that, you know what I say? Is that the question? Amazing. Any other questions with this so far? We only have a state variable that is an address where we are going to store the address of the owner. Okay, and then let's just implement here the constructor. Good. Oh, yeah. So for the constructor, what we want to do is to set this owner variable that we have here. So there are different ways that we can do. Let's say if I come to MetaMask and I know that this is my address, I can hard code this and just say, I am the owner of this smart contract, right? And that's fine. That's not really like a good practice, but you can do that. And then only this address will be able to withdraw funds from this smart contract, because we are going to see that in the withdraw function, we are going to do like a if, that only the owner can withdraw the money. But then there is another global variable that is called message.sender. And this message.sender is the address, the person that is deploying the contract will be the message.sender, the person that is sending the transaction. When you deploy a contract, you are sending a transaction to the blockchain, and this message.sender is catching that address of the wallet that is sending the transaction. So what we are doing here is kind of setting the owner with the address that is deploying the smart contract. I don't know if this part is clear of this line 11. Is the line 11 clear? Yeah, no questions? Don't be shy. I can repeat everything. I don't have any issues. Okay, so I guess it's clear. We are just setting the owner of the smart contract that we are going to use later. Okay. Oh, and then here in the smart contract, there is another way to do it. Yeah, this is a different way. Instead of, let me just put the comment here. Yeah, so with this constructor, the address that is deploying the contract will be the owner. Or if we do a different way, the constructor, let's say the constructor can receive a parameter. So this is a different type of initialization. So what will happen, let me just comment this here. What will happen in this case is that instead of directly putting the deployer of the contract as the owner, we can just send in the parameter a new owner. So let's say I deploy this contract, but I can set you as the owner. This is the only difference with this type of constructor. But then in the first one, this one here, if I deploy the contract, I am the owner. Is this clear, these two types of, it's loading. Is this part clear? Anyway, we can only have one constructor per contract, but I just wrote both so you can see the differences. But yeah, let's just stay with the first one. Okay, and now let's implement this receive function. This receive function is just something by default that you need to put in the contract if you want your contract to receive ETH. If you don't have this receive function, your smart contract will not be able to receive ETH. And this is just an empty function. You don't need to do anything. Just show it here. Yeah, this is literally the function that you need to write. So we just put receive, external payable, and then empty. Nothing else. That's something that we need to have with all the Ethereum proposals and things like that. This is just a standard that you always need to include in your contracts if you want to receive ETH. That's the only thing with the receive function. Any questions so far with this? Perfect. Okay, so far we implemented two functions, the constructor and the receive. Now let's implement the third one, which will be the donate function. Yeah, so this function will be receiving the funds that other people will send to my contract. And I have here the implementation. Yeah, perfect. So let's just put here function, donate. Okay, something else that you need to know is this external. There are three types of functions here: external, internal, and public. External allows anyone from outside of the smart contract to interact with this function. So if I put internal, this function cannot be called from anyone. That's something that you need to understand as well. And also private can only be called within the smart contract. Let's see if I have an error here with the license. Can be the error. Oh, yeah, it's fine. So yeah, this is the first thing. I just call it function, donate, that's the name of the function. It's external because anyone from outside can call this function. And it's payable because this function will receive funds. When we create the other functions, they will not be payable because they will not receive funds. The first thing that we need to do here when we implement this donate function. Oh, I will need my charger. Just 1 second. Do we have any USB-C charger? I mean, I have one, but I don't have this thing. It's USB-C? Oh, this works? Oh, what happened? I don't think so. I can sit here. Okay, well, I will just sit there. Oh. Let's put this here too. Wow. Thing is, now I don't see what I'm typing. There is no anything there. Okay, yeah. Maybe that would be better. Oh yeah. Okay, so this donate function basically only has 2 lines of code. Okay, the first line of code, what it's doing is just getting the address of the smart contract. Oh, can you connect that again? It's just getting the address of the smart contract, because we are going to make a transfer to this address. So to get that, we need to type this, and that's how we get the address of the smart contract, because then we are going to transfer the funds to this smart contract, and to do that, we need to write, just go through this contract dot transfer. So that means that we are transferring to this address. Oh. Okay, 1 second. Jesus Christ. You see that is not changing now? Okay, now it's showing again. Oh, but it's delay. So we are just basically making a transfer to send, to send message value is the value that we are going to send in that transaction. So what we are going to do is this contract dot transfer message value. So what we have is to this address. Wow. Okay, it's slow. No, but I already wrote that. Okay, just 1 second. I don't know why is that slow there. Oh yeah, I think it's the computer actually. Yeah. I don't know, where is Abdi? I should ask Abdi to change that. That's just got stuck there. Okay, the computer just kind of crashed because it's not updating there. Is Abdi here? Wow, we're having a big issue now.
The problem was this, it's not working on this computer.
Yeah, okay, I think it's working now. Yeah, so what we are doing is transferring the message. Yeah, it's working now. Transferring this message.value. Message.value is the value that we send in the transaction. I'm going to show you that in practice, and then I'm going back to the code so you really understand this smart contract today. But what happened is that this contract needs to be payable because we are transferring funds to that contract. But if we want to send funds to another address, just for you to have a reference, let's say that we can put payable, and then I can hard code my address here. Yeah, payable my address, or let's just put it here. This is just an example of how you can transfer funds in a smart contract. My address. Yeah, my address dot transfer, and then we can just transfer message dot value. Or let's say if we put 1, then we will transfer 1 ETH. Put this. Okay. Oh, it's not. Oh, it's the other side, yeah. Are you able to understand this part of making transfers with the contracts? And let's say in this case, we are transferring, in this line 22, we are transferring the funds to this smart contract. But because we are handling the donations and the withdrawal in two different functions. But if you want, like maybe you say before, we can directly transfer using the line 25. And if we use the line 25, we are directly transferring. When you send the funds are being sent to me right away. So that's the way to send the funds directly. But then with the line 22, what we are doing is sending the funds to this smart contract, and then the contract will have the funds. We'll just kind of raise the money. So you have any questions with this function so far, with the donate function? Yeah? Between the donate and which one? Oh, okay. The receive is just something that needs to be written if you want your smart contract to receive ETH. But the receive is not receiving the functions, the funds. That's just by standard. Like for example, if you ask me what is the functionality of this license, that doesn't change anything, right? But then it's the same with this receive function. It's just a standard that you need to have if you want your smart contract to receive funds. But when we deploy the contract, let me deploy the contract in the Remix virtual machine. You can come here in the left, and you can come to deploy and run transactions. After you compile, oh yeah, in this case, my smart contract is already compiled. You can see compile Zetech, or you can click here in auto compile, and then it will compile your smart contract. Once it's compiled, you come to deploy and run transactions. And then we have something called Remix virtual machine. This Remix virtual machine will give you like 10 accounts. Let me just zoom in. Yeah, we'll give you 10 accounts with 100 Ether. This is testing Ether as well. So what we can do is kind of deploy the contract in this Remix virtual machine to play around, just to test. But then after that, we are going to deploy to a real testnet and to play with the contract. But what we can do is to come here to deploy. So when I click in deploy, we will see that the transaction was successful. Yeah. And then when you scroll down, we have deployed contracts here. And basically, we have the Zetech contract here. And the only function that we have is the donate. So here we will see all the different functions that we have in the smart contract. And look that the receive is not there. Receive is just by standard that we need to put it. And the balance of the smart contract right now is 0 ETH. And let's say that I want to transfer it to the smart contract. To do that, we need to come here to value. We can choose 1 Ether. And then I can send 1 Ether. I click donate. And now you can see that the balance of my contract is 1 ETH. Is that part clear so far? What I did was, for testing, I deployed the contract, and then I sent 1 ETH to the smart contract. So this contract has funds right now. Is this part clear? I mean, this is testnet. This is not like real blockchain, but yeah. Do you get this concept? Someone has any questions? Yeah? Oh, okay, good question. What is the external thing? So if I put, let's say, internal, and then I will redeploy the contract. Oh, this cannot be payable. Let's say I put internal. Oh, it's not updating. Wait. It's delay. Okay, yeah, so what I did is that instead of external, I put internal. And then I will just redeploy the contract. To show you, okay, so I will come here again. I will click in deploy. And then when I deploy the contract, I will see the contract here. And now that, look that I don't have any functions. There is no donate function, right? Because I put it internal. So that means that no one can call that function, only the smart contract itself. So that's the function of this external, internal, or public as well. Public is similar to external, it's the same. And then the payable is that this function will be able to receive funds. That answer your question? Perfect. Okay, so far we just implement the function donate and the receive and the constructor as well. Now, oh yeah. Now we are going to implement the function withdraw. So this withdraw function, what we will do is that when we call the withdraw function, it will send the funds to my address. There is updating there. There's a little bit of delay. Jesus. Wow. It's not changing. Why up the left? Yeah, the screen is just frozen right now. Jesus. Okay, what I'm going to just write the function and then just walk you through the code. That will be faster. Oh, okay. Okay, so I just implemented the function withdraw. So this withdraw function is also external because anyone can call this function. But then we have 3 lines of code in this function. The first one is a require statement. So this require statement says that the address that is sending the transaction, which is called message.sender, needs to be the same as the owner. And remember that the owner is the owner that we set in the constructor before. So that's the first require statement in the function, that will only allow the owner of the contract to withdraw. If this is not true, when we run this and we go through this require, then this will just cancel the execution of the contract and will not send the transaction. And then it will show you this string that is say you are not the owner. Then after that, in the line 31, we are fetching the balance of the smart contract by using this address this dot balance. This is how we access to the smart contract object within the smart contract. And we are just storing the balance in this current balance variable. Yeah. And then after we store this balance, we just make the transfer to the owner. So we are putting here owner.transfer current balance. Is this function clear? You want me to go through this again? I can explain again or in a different way. Do you all understand the function? Yeah? Okay. So now what we can do is to test it in Remix again. So I'm going back here. Remember that we are in this Remix virtual machine. And then I just deploy. Perfect. It deploys. Here we see the smart contract with these 2 functions, donate and withdraw. So let's say that I'm going to donate. This account that is the owner, the account number 1, has 98 ETH, as you can see. Yeah. So I will donate 98 ETH to the smart contract. So I'll scroll down, and then I will click in donate. Okay. Now what happened is that our smart contract has 98 ETH because I just donated that, and then our account has only 0.9 because we donated everything. So now I'm going to change to the last account, this one, and then I'm going to try to withdraw the money. And then, because we are changing the owner, do you get this concept that I'm changing the account? So now I'm going to call the function from a different address, which is not the owner. So if I try to withdraw, it will show us an error that says you are not the owner here. Because when we call this withdraw function, it goes to the require and it's saying basically expecting that this address number 1 is the owner, but we are making the call from this one. So that's why it's not the owner. But then if I can donate with that account too. So I will take the last account and then I will donate 99 ETH. Okay, it's loading. taking some time. Perfect. So I just selected the last account with 99 ETH. I put here 99 to donate 99 ETH, and then I call the donate function. And now our smart contract has 197 ETH because we donated. And then if I go back to the account number 1, and then I click in withdraw, this will work, and now we see that the smart contract has 0 ETH. And then if I check the balance of the account number 1, we see that account number 1 has 197 ETH, because what happened is that that account called the withdraw function and it worked, and it just transferred the balance of the contract to that account. Do you have any questions with this part of donate and withdraw, these two functions? I can go over the contract again. Perfect. Then I think it's clear. Basically, that's a smart contract that we have just to donate and withdraw. And then the last function that we can implement is called get current balance, because when you want to interact with the smart contract using JavaScript, we need to call the functions to know what is the balance of the contract. In this case, Remix has a nice interface and it's showing us a nice balance here, but in real life we will not get that, that function like that. So that's why we need to implement a function that shows the current balance of the contract. So let's just implement the function here. That's a reading function because it's only retrieving information and it's not changing anything within the smart contract. So function get balance, and this is external view returns. So all the view functions are the reading functions, the ones that you don't need to have funds to interact with these view functions. But then you always need to have funds to interact with any external functions of a smart contract, because you are sending a transaction. But to fetch the balance, you are not sending any transactions. You are not changing anything in the smart contract. So to fetch this, we just need to type return address this dot balance. And that's how we can return the balance of the contract. Oh, we need to put here uint256, because we are returning a uint256. And then I can also implement another function just to get the owner. Let's say that I want to know who is the owner, right? So I can put function get owner, external view returns. Then this will return an address. And then return owner. Do you guys have any question with these two functions, the get owner and get balance? Perfect. So then I will just redeploy the contract. Every time that we update something, we need to deploy the contract again. So I will just remove this instance. I deploy the contract. Then we have the new contract here with these functions: donate, withdraw, get balance, and get owner. So when I click in get balance, we see that the balance is 0. And then if I click in get owner, we see that this is the owner of the contract. So only this address will be able to call the smart contract. This address ends in DDC4. And when we check here, this is the DDC4, because that's the deployer of the contract. And then, yeah, we already interacted with these two functions too. So do you guys have any question with this part of implementing the smart contract? Yeah? Oh, wait. That's too low for me. Wait, I'll go there. If what?
If the withdraw function, we say the withdraw function to external, meaning anyone can call it, but only the owner can
Withdraw?
Can withdraw. If you were to set it to internal, will the owner be able to?
Oh, good question. Okay, that's a good question. If we change the withdraw function from external to internal, can the owner, only the owner, call this function? No. When we put internal, this function cannot be called by anyone else. Like, no any wallet will be able to call this function. Because if you saw, let me just put here, if I put this internal, And then I just redeploy the contract. Okay, it's loading. Now you will see that there is no withdraw function. So this contract can only donate, get balance, and get owner, but will never be able to withdraw. So the funds will get stuck in that contract. That's why if you write a bad smart contract, you will need to be really careful before you deploy that. Because if I deploy this to the blockchain now, it can receive the donations with the donate, but we can never withdraw the money from the contract. And then the money will get stuck in that smart contract. So that's why, yeah, you will always need to test the smart contracts and everything. That's why a smart contract developer and also auditor and security is really well paid, because you are playing with funds here, right? So that's a really important part of the blockchain. So I will just set this to external. So yeah, to answer your question, we need to put it external or public as well. That's basically the same. Oh, okay, that's the other computer. Wow, and the battery. Where is Abdi? Now Abdi's not here. Yeah. Okay, now let's wait. Let's drink water for now. Sorry, by any chance, do you have an adapter? Like an adapter, because I have a charger for my computer, but it's not. Yeah, but that's not my computer's charger. And look, let me show you. I have this. Let me show you what I have. This one. You know?
Let me see.
Yeah. So I need.
You can try somewhere.
Yeah. Okay, let's wait and drink water. Do you guys have any questions so far? Yeah.
You say JavaScript is better than Python. Why is that?
I don't know Python. That's why I'm a JavaScript lover. No, but then because it's more used. Also, if you check the statistics, there are more developers in JavaScript. There are more things for JavaScript. And everything that you can do with Python, now you can do it with JavaScript too, which is all the machine learning and AI can be done with JavaScript too. And I prefer to be really good at one than to be medium at two, right? So that's just my personal opinion, but yeah, it's for sure there are people that love more Python, but I'm more like a JavaScript maximalist. Okay, this work again. Oh, amazing, you got it. Yeah, and then just put it there. Perfect, we're the best. Let's see if it works. Yeah, perfect. Okay, so I just want to go over this smart contract again to make sure that you guys understood everything. Oh, that's got stuck again. So the first thing that we have in the contract is the license. This is always by default like that. I just always put the MIT. Then the second thing in the line number 3 is the Solidity compiler version. In this case, I put 0.8.0. I think the latest one is 0.8.22, something like that. Then after we put the license and the compiler, we create an object that will be a contract object that I call Zetech. Okay. Then we always have state variables. And when you, for example, when you create a token, just to give you a reference, I don't want to overwhelm you with more information, but just to give you some ideas, you will create a mapping that will store addresses to balances. So it will be something like this. Oh. Yeah, so this is basically the state variable that you create when you create a token, a mapping of addresses with the uint, which is the balance, and then this mapping will be called balances. But yeah, we are not implementing a token today, but just to give you an idea, you will have these different state variables. Then after that, we create the constructor this constructor will set the owner of the smart contract to the address that deploys the contract, that send the transaction to deploy a contract. When we deploy a contract, we are sending a transaction because we are writing in the blockchain a new contract, so that's why it's called writing functions or sending transactions. Then we have these two reading functions, get balance and get owner, that will just return the balance of the contract and return the owner, just for us to be able to see who is the owner of the contract. Maybe in our dApp, for example. Oh. Okay, and then the writing functions. We have two functions. One is the donate. This donate will handle the donations. So this is allowing external users to send funds to the contract. And then we have a withdraw function that will allow only the owner. That's why the statement in the line 34 is really important, the require statement. Because if we don't write this require statement, anyone will be able to withdraw the funds. Okay, it's got stuck a little bit. Maybe you can turn off the microphone. Yeah. Okay, perfect. But actually, if I remove this require, what will happen in line 40 is that anyone can call the withdraw function, but at the end of the day, they are transferring the functions to the owner. Because in line 40, we are saying transfer all the funds of the contract to the owner. So it will not be that bad, but it's just a little bit weird that you call the function and then I receive the funds. It's like when I want to withdraw, I will receive the funds. And if we change this to message.sender, then in this case, the person that calls this function will get the funds for themselves, if I don't have this require statement here. Yeah, do you guys have any questions with the implementation so far of the contract with the functions? Because now we are going to create a React app to interact with this contract. So I want you to at least understand the functionality of the contract. Is that clear? No questions? Yeah? To withdraw a specific amount of money. Yeah. So the only thing that we will need to do is to change this variable of the current balance. In this case, I'm withdrawing all the balance of the contract, right? From this line 37. But then if you want, what we can do is, let's say, we can create a UN256 with amount. And then instead of transferring the current balance of the contract, we can just transfer the amount. Okay, it's loading. Okay, it's loading. But what I changed is, instead of current balance in line 40, I just put the amount that we are sending in the parameter of the, as an argument in the function. But okay, yeah. Okay, now as you can see, the amount that we are withdrawing is this one. Oh, I guess is this one. That's what you mean? Yeah. But yeah, for the purpose of the workshop today, let's just withdraw all the current balance of the contract. Any other questions? Yeah?
So what is like the code use case between external and internal?
Perfect. That when you have internal functions, that can be functions that will have internal logic in the smart contract. Like for example, let's say that we want to make a math operation of function. Okay, maybe I have an idea now. Send fees to Gideon. Internal. Okay, and what happened here is that we are going to have an internal function that we are going to call here. Funds to, oh, send fees. Yeah, fees. Send fees to Gideon. And then let's say that here in this send fees to Gideon, what I am doing is Gideon address dot transfer 1 ETH. Okay, just for you to have an idea, what I'm doing here is this. I created this internal function that every time that we call the withdraw, look that in line 38, in line 38 is calling this send fees to Gideon. So anyone can call the withdraw function, but then when this smart contract executes the line 38, we'll call this internal function that will send 1 ETH to Gideon before we withdraw the whole amount. Oh, it's still loading there. But then no one will be able to call the send fees to Gideon function because that's internal. But then internally, the smart contract, we have this logic that when we call withdraw, we are calling the send fees to Gideon function. You know what I mean? That clear? Perfect. But yeah, it's not loading there. Any other questions while the computer comes back? No? Oh, okay, it's not coming back. Okay, I think it almost works. The internet is really good. Okay, so now the fun part will start. We are going to deploy the contract to a testnet, which is Sepolia. But hopefully the computer comes back. I mean, I'm there. Because my internet is really good. I don't know why. Internet is good. I think the internet is good. But look, I'm sharing. The mic? Oh, where did you put it? The microphone? Oh. Yeah. What? For me? For what? I don't want to say anything. Oh. To speak, okay. Okay, I think that will be fine. Anyway, we cannot really speak without the screen for now. But yeah, what we are going to do now is to deploy the contract to Sepolia testnet. Ooh, okay, it's coming back soon. Remember that you will need to have testnet tokens to be able to deploy the contract to any testnet. So if you want to deploy, okay, this is a really eyes opener statement that I will say right now. The same smart contract that we just have right now, we can deploy this to Ethereum or to Sepolia or to Polygon or to any other Ethereum virtual machine just by changing the network of the MetaMask. I'm going to show you that soon. But the same smart contract can be deployed in any network. That's a really nice thing that when I was learning, I was able to understand that we can deploy the same contract in any EVM network. And then I'm going to show you how that works soon. No, but my internet is really good. No. I mean, my internet is from this one, Zetech internet. Yeah, Zetech internet.
Oh, yeah, it's working. You can try and share.
I'm sharing.
No, maybe try it.
Or, okay, I think we are back. Oh no, we are not back. Almost.
What's happening now? I think somebody needs to mind their hotspot.
Oh, I can't even see myself here. There is not, look, here I turn on the camera and there is not working.
Yeah, it's not working.
And if you connect, you cannot. Ooh, I think we are back. Just a little bit delay. Let's see. And it didn't work to connect another computer. Maybe that computer is slow. Oh yeah, That's us. Okay, so we are back, but that was like 2 minutes ago when I turned on the camera. So it's a little bit delay. Let's see if it works. Yeah, for now, then just download MetaMask, get testnet tokens. You can just Google testnet tokens Sepolia or testnet tokens Mumbai. So every main like blockchain or layer 1 or layer 2, they will always have their testnet network. So Ethereum mainnet, their testnet network is Sepolia. So we have Ethereum Sepolia, Polygon, the testnet is called Mumbai. Then for CK Sync, we have CK Sync Sepolia. For Optimism, we have Optimism Sepolia. I don't know why Sepolia, but always the testnet is called Sepolia in most of them. Okay, I think we are back. Let me see. Yeah, mine is working, but it's a bit delay. I think it's working now. Yeah, it's working. Okay. Okay, so what we are going to do now, it's fine. Yeah, it's fine. Is in here in the top left, we see the environment. So I'm going to change the environment instead of Remix virtual machine, which is this, let's say, testnet machine that gives us 10 accounts with 100 Ether. I'm going to change to injected provider. Injected provider is the MetaMask account that I have. And then as you can see, I'm going to deploy the contract from this, let's say, Vault account. I'm going to deploy that on Sepolia. So that's really important to change the network. Here in the top left of MetaMask, you see the networks. Okay, it's loading. Yeah. And then I'm going to check, okay, to change to Sepolia. Yeah, I think it's slow. So that's my balance in the Sepolia testnet. And from that account, I'm going to deploy the contract. But it's just froze right now, frozen. The only thing that you will need to do is just to change the environment. Things coming back. It's coming back or leaving again. It's leaving. Okay. We're a little bit in slow motion with the deployment. The internet is good. I don't know why it doesn't work. Do you guys have issues with the internet? I have really good internet with the Zoo guest. Oh, it's working now. It's working now, Gideon. Yeah. Okay, it's delay. Okay, so in that case, you can see that account with 0.3 ETH because I already have an account connected. But what I'm going to do is I'm going to disconnect the accounts because if it's your first time in Remix, you will see no accounts. Yeah. So as you can see, there is no accounts now. Then if I click in injected provider again, okay, it's loading. So when you click in injected provider and if you never have connected an account, it will pop up MetaMask here. And then it will ask you like, hey, connect one of your accounts that you have in Remix. So in that case, I'm going to choose this account that is called Vault, where I have 300 something ETH to use that account for the testing today. So I just check box that, I click in next. Then I click in confirm. And now you can see that here is my account connected with 369 ETH. So right now we are connected to Sepolia. And then if I click in deploy here, we are not deploying to the testnet Remix virtual machine, we are deploying to the Sepolia. So that's what I'm going to do, and I'm going to show you. I click in deploy, and then you can see the MetaMask popping up soon. Okay, not that soon. Okay, so MetaMask will come soon there. Oh, I think it's leaving again. I already know that little sign. Yeah. Is this your water? My water. Right. Yeah, it's frozen again. Oh, okay. Okay, we are back. So when I click in the deploy button in the left, in the orange button, MetaMask just pop up asking me to confirm the transaction. In this case, the transaction is a contract deployment that you see here. I don't know if it's really visible. I'm going to select that, to highlight that in blue. Here is saying Remix ID, sending a transaction for contract deployment, but it got stuck a little bit. I think it's not the internet. I think it's the computer, maybe. I mean, let's see. Oh, okay, yeah. Now it came back. So you can see that here it says contract deployment in the blue part that I highlighted there. Then we can just click in confirm in the bottom right button that says confirm. And then when I click on confirm, that's just sending the transaction, but you cannot really see it yet. Okay, it's sending the transaction, and then in the button, you will see when the screen updates. Yeah, so it updated right now. Here is showing this little green check. That means that the transaction was created. And then when I expand that, it shows the status of the transaction, which was transaction mined and execution succeed. The only important thing from here is the contract address. It's loading there. So every time that we deploy a contract, we are getting a response that is called receipt. In this case, the receipt includes the contract address. So we know, okay, I deployed this contract, then tell me what is the address of this contract that I just deployed. So the contract address is here, but it's not showing there yet. Oh yeah. So this one is the contract address. I'm going to copy this contract address. And then you wonder, okay, I deployed this, and where is the blockchain, right? We want to see the contract. So we can come to sepolia.etherscan.io. And this is a block explorer where we can always see the different blocks that are being mined every 12 seconds, the different wallets, the different contracts that are being deployed. We can literally see everything there. So sepolia.etherscan.io. And then the block explorer of Ethereum is just etherscan.io. But because we are using Sepolia, sepolia.etherscan.io, but it's not showing there yet. Then let's wait a little bit. Wow, it's almost 5. And I think this space is until 5. Maybe you can ask Abdi until what time is it? Yeah, just ask him until what time, so I know what to do. Okay, we are back. Okay, so as you can see now, I am in sepolia.etherscan.io. And then in the search bar, I just copy paste the contract address. Okay, and then, but another thing that I'm going to do is to copy paste actually my address to show you what I did here. So if I go to Etherscan and then I put my address of both address, you can see all the different transactions. Okay, it's going to show it soon. All the different transactions that I have done from my account. Okay, perfect. So now now it loads. And then you can see that 2 minutes ago, here 2 minutes ago, we sent a contract creation transaction. Oh yeah, is there loading? Perfect. And then if I go to that contract creation, now we have the contract address here. I just click in contract creation, and now this is the contract. And when we click in contract, we see that we have nothing, just something that is called bytecode. Bytecode is like the low-level language of the smart contract. But what we are going to do is to verify our smart contract, so anyone will be able to see what is the code of the contract that we deploy. Because it doesn't make sense that in the blockchain you interact with contracts that you don't know what they're doing. So that's why, for transparency, what we always do is that we verify and publish the code of the contract in the Block Explorer, so everyone can see what is the code that you are interacting with, but it's not loading there. Yeah, I don't know. This is a big issue because it's really like slow. Wow.
So like 10 minutes of load.
Yeah. Basically, I just click there in that contract part, but it's not refreshing. Yeah, instead of giving the share, he should find a better solution for the computer. Yeah, I think we are having a big issue with this. Abdi, so that's basically not working. I mean, it's not refreshing. I clicked there like 1 minute ago. Yeah, it's not refreshing. We need to invite everyone to JQuad so they can do the whole workshop. We need to invite everyone to JQuad so they can do the whole workshop. I think it's the computer. The computer crashing, not the internet. Okay, now it loads. Okay, so I just click in contract. Then you will have this verify and publish in blue. I'm going to click there. Oh, I hope it's okay.
Maybe this will solve the issue.
Okay, so when I click in that verify, and publish, we see this screen. What I'm going to do is to verify this smart contract. The address is already there by default. The compiler is a single file because we just have a contract with is one file. When we use like inheritance and we use other smart contracts, then it will be a multi-file. But then in this case, it's only one. The compiler version 0.8.0. The license MIT. Then we click in continue. It's a little bit fast now. Oh no, got stuck again. So I just click in continue there. No. And then here it will ask me for enter the Solidity contract code. So I'm just going to remix. I'm going to copy paste the whole code of the smart contract. I paste it there. And then we just scroll down and we click in verify and publish. Okay, and then it says that successfully your contract has been verified. And then when we go to the smart contract, we can see that here in the contract we have this little green check because we already verified the contract. So when someone wants to interact with this contract, they can come here and they will see the code of the contract. Contract Zetech, state variable, the constructor, everything. So always when you interact with contracts, try to interact with verified contracts. I mean, there can be also malicious code here. In this case, it's not malicious code, but that's what you need to be really careful. And that's why when you learn Solidity, you will be able to understand what I am interacting with with this smart contract. Then we have this type of functions, the read contract and write contract. Loading. Yeah. Okay, so in read contract, we can see that the get balance is 0. And then when I say get owner, we get this address. And this address is basically my MetaMask account with the same that I just deploy. When I click here in search, you can see that it's the same. And then in write contract, this is already in testnet, so we just deploy the contract to testnet. We have these two functions, donate and withdraw. So to donate, we can send the money here. The thing is, I wanted to do the scripts. I actually wanted to make a whole dApp to interact with the contract, but I don't think we'll have time. I don't know what to do. Maybe, do you think that if you want, guys, I can do quickly like maybe at least the scripts to interact with Web3.js, to interact with this contract using code. And then the only thing that you will need to do basically is when you create a React app, you will need to use these scripts. Or maybe let's see if maybe let's just try with this. Why not? Let's try the React app. That will be better. So I just created this React app earlier before. I'm going to open the React app. And I'm just going to edit the app.js code. Let me just remove this. Okay, so first thing that we need to do is to install the Web3.js library by running npm install web3. Okay, it's a little bit fast. Okay, something that you need to know is that we will always need something called an ABI to interact with the smart contracts. To get this ABI, you can come to code here in the Block Explorer. Then you scroll down and you will find this contract ABI. That's always needed when we want to create a contract object in JavaScript to interact with the contract. So I will just store the ABI here in the React app. ABI, cons ABI. So I just copy paste the ABI that you saw there, export default ABI. Then I will import the ABI in my React app. I will also import Web3.js. To import Web3.js, we need to type import Web3. Just put it like this. Import Web3 from Web3. Okay. And then I will create a function. First, I'm going to interact only with reading functions, which is a little bit faster. So async function get balance, and then async function get owner. So we are going to interact. Oh yeah, it's crashing again. Oh yeah, that's. So I just created these two empty functions. First thing that we need to do is to initialize the Web3 object. So to do this, we just need to type const web3, new Web3. And then in parentheses, we put window.ethereum. And with this line of code in line number 9, we are kind of connecting to the MetaMask in the browser. So when the user goes to this app, it's connecting to the MetaMask or any wallet that the user has in their browser. And then let's initialize the contract. So const contract, new. Okay, to initialize a contract, we need to type web3.eth.contract. And then this will receive two parameters, the ABI, that's why we always need an ABI, and then the contract address of the contract that we are interacting with. So I'm coming back to Scan. Here we have the contract address. Then I will just put it here. Okay, so I just initialize the contract instance. Okay, it's slow. And basically, yeah, so basically what I did was in line number 10, I have the address of the contract, and then in line number 11, I created a new instance of the contract by typing new web3.eth.contract, and then I pass the ABI and the address of the contract as a parameters. And then if we want to interact with that contract, which is in Sepolia, we can just type contract.methods.getBalance.call. And then we are going to store this in a variable, let's say result. Await, okay, and then let's console log this. Balance. Do you guys have any question with this line 14 and 15? Basically, we just type the contract instance that I just called contract. We can just call it contract instance. Dot methods. Dot get balance. So the other one will be the same, but we just put the get owner. And that's the only thing that we need to change to call reading functions, then dot call. So I will just do the same. I will just copy paste this in the get owner function. Owner, and then here get owner dot call. Yeah, we just need to make sure that this function is the same name of the contract functions. And yeah, we have it like that, get balance and get owner. And then let's just create a button to interact with those two functions, get balance and owner. One click. Get balance, get owner. Okay, so I will just walk you through this code again. I created these two buttons, and then when you click on this get balance button, it will interact with this get balance function, and then the same with the get owner as well. And then here we are interacting with the contract instance .methods.getOwner.call. This .call is because we are just calling reading functions. So let's see if this works. So let's just run npm run start, I think. Yeah. npm run start. Then we just run our React app. Okay, so I have the React app with these two buttons. So something really important is remember that the contract was deployed on Sepolia. And the app is connected to our MetaMask. So if in my MetaMask right now, I am connected to Ethereum mainnet. So that will not work if I don't change to Sepolia. That's a really important thing to know. So I will just change to Sepolia. Okay, it's taking some time there. I changed to Sepolia now. And then I will open the console. And then if I click in get owner, let's see if this works. Yeah, get owner, and then we got the get owner here. Just put this. Okay, then yeah, this is the owner. And then if I click in get balance, we are getting the balance of the contract, which is 0 in a big int. So right now we are interacting with the contract in Sepolia. But if I switch my network in MetaMask to Ethereum, for example, and then I try to interact with the contract again, if I click in get owner, we will get an error that is saying return values are not invalid, because what is happening right now is that we are trying to call this address, this address in the Ethereum mainnet, but there is no contract in this address in Ethereum mainnet. This contract only exists in Sepolia. Another thing is impossible to deploy two smart contracts with the same address. The same with the addresses and private keys. Supposedly only with quantum computer and something like that can happen. But yeah, so far it's impossible to find a contract, two contract addresses the same, or two addresses the same, or two private keys the same. That's not feasible at the moment. So yeah, what we did so far was to interact with this contract to get the owner and get the balance. Do you have any questions with this? Is that part clear? I'm going to also put this on GitHub, so you will be able to check the code. That will be easier as well. No questions? Yeah. That's a good question. If you are able to get any amounts of test tokens, no. There are different faucets, and those faucets will give you like, let's say 0.05 tokens a day. But if you need tokens, you can let me know, because here I have like 300 something tokens, testnet tokens, in case that you need something. Or when you need another amount, you can also reach out to, depending on the team, someone on Twitter, or if you are doing something in Celo, you can reach out to the Celo team. Hey, Celo, can you give me 1 million of tokens? I'm deploying this dApp and I need some testnet tokens, and then they will do it. But yeah, normally you can only have like 1, 2, 3 tokens per day for the testnet tokens, testnet network. Any other questions? Yeah?
There are functions that will allow refunds to the other addresses apart from the owner.
To what, sorry?
There are functions that will allow refunds to the other addresses.
Refund the addresses.
The other addresses that have been routed to the smart contract.
Like to, what do you want? To refund those addresses or to store those addresses? Oh, I don't understand the function. To know. Or to know the people that are donating. To refund their funds. No, because we didn't create that function. But then if we go to our smart contract, we can create a function that is called refunds. And then what will happen? Then we will need to change several things. First, we will need to go to the state variables. And then we will need to create an array of donators. I don't know what's the word in English. Donors. And then what we can do in the function is to iterate through this array and then send the transfer to all the donors that are in that array. I mean, we don't have it here, but we can do something like that, and that can be possible. Yeah. Any other questions? Okay, I think we have some time then to also interact. Right now, we interacted with these two reading functions, but then let's interact with these donate and withdraw functions. So we need to do something called request account. So we need to request the user to connect the accounts. So I will create a function, connect account. And to request the user to connect the account, what we need to do is to type web3.eth.requestAccounts. And this will return an array with the accounts that the user connected. So accounts. Okay, so I just created this. And then I'm going to create a button to interact with that function. Connect accounts. Connect accounts. Okay, so what I'm going to do is just to test that button to show you. Who from here is not familiar with use state in React? Everyone knows use state? Okay, because I just wanted to add that. So use state will just allow us to render some information in the front end. I don't like to put a lot of code here, but let's do that one. Use state, no account. Okay, so this use state, what I'm going to do is just once the user connect an account, I'm going to render in the front end the account that the user connected. So here is connecting account, and then here is rendering in the app. Set accounts in the slot 0. Perfect. Remember that this accounts is an array of accounts. We are going to use that one right now. And then let's put that here. Accounts connected. Account. Yeah. So as you can see, right now we have no account. Just put space. Yeah, so accounts connected, no account. I'm just going to check that I'm disconnected. Yeah, right now I'm going to disconnect my accounts from the React app. So when I click in connect accounts, you will see that MetaMask will pop up. And then we'll ask, like, hey, user, connect the accounts. So I'm just going to connect one. When I click in next, confirm, and then you will see that the account that I connected was that account. So that's how we can connect the accounts to the dApp. And then we only have access to the address. We are not having access to any private keys. From the app, we are just having the address of the user with this line of code, web3.eth.request accounts. So yeah, we need to use that. I'm just going to return that accounts, the slot 0. Okay, and now let's create a function to interact with the donate function in the contract. So this is similar to the calls, but the only difference is that we need to type send. So contract instance.methods.donate.send. Then in this .send, we need to send an object with the from property, and this from is the address that is sending the transaction. In this case, the address that will send the transaction is the address that was connected in MetaMask. So that's why here I will call the function connect account connected. Wait. Okay, so what I'm doing here is just calling again this function that will return the account that was connected. And then I'm going to use that account connected here to send the transaction from that account. So in line 27 is the magic of interacting with the donate function. So contract instance.methods.donate.send. And then this will return the transaction receipt that I'm just going to print that in the console. Transaction hash. Okay. So now let's see if this works. I'm just going to create a button to interact with the donate function. Oh, something important, I forgot to add that, is that I'm going to hard code the value that we are going to donate. In this case, we need to send from, and then also the value that we are donating. The value that we are donating, in this case, I'm just going to hard code 1. 1 is one way. Who don't know what is way and ETH? The difference between way and Ether? Okay, so let me show you. That's just the different measures of units in Ether. So 1 Ether is 10 to the power of 18 way. And normally when I write 1, I'm just sending 1 way. But then 1 way will be this 0.0001 Ether. So always we are interacting with way, but just to have the measures, that's really important to understand these two different concepts. Way is the minimum value that we have in the blockchain. So when I put here value 1, we are just sending 1 way, no 1 Ether. That's important to know. Let me just go back to this. So now if I click in donate, let's see if this works. MetaMask will pop up. And then it will say that we are interacting here. You cannot really see. But here is putting donate. That's the name of the function that we are calling. And then you are sending 0.0001 ETH. Then I click in confirm. Then let me just open the console. And then we are going to get a transaction receipt once the transaction is done. Yeah, so this is the transaction hash. So if I take this transaction hash and I go back to Etherscan and I copy that transaction hash, we are going to see the transaction that we just sent that is a donation. You will see it soon. Yeah, it was success. And we just send value 1 way here. And we interacted with the donate function here. So if I go again to my app and I click in get balance, it's loading, and I click in get balance, the balance should be 1 way now because we just donated 1. And then you can see that the balance here is 1. It's loading. In the console, you will see 1. Yeah, now you can see that the balance is 1. Let me actually just render that in the front end really quick. Cons balance, set balance. And then the get balance, set balance. Okay, so I just updated this to render the balance in the front end. And then if I click in get balance, slow. If I click in get balance, you will see that the balance is 1. Then if I click in donate again, I'm going to donate another way. Confirm. Then let's wait that the transaction is executed when we get the transaction receipt that I'm printing in the console. Okay, now it's done. Okay, it's not showing there yet. Okay, got stuck again. Okay, the screen is frozen again, but yeah, I just sent it another way. And then if I click in get balance again, we will get 2 because we just donated 2. We hard coded this value, but yeah, normally you should have like a input form that you allow the user how much you want to donate instead of hard coding 1. Update that, got stuck again. Oh, okay. Yeah. But basically that's how you will interact with contracts. Remember that you only have those 2 types of functions, reading functions and writing functions. In this code, you have the code to interact with both of them. And, oh, okay, I think I updated now. Then if I click in get balance, now the balance is 2. Or if I hard code this value to, instead of donated 1, I can donate 100 way. Okay, got stuck again. And then if I just donate 100 way, oh yeah, you see it there. And then I click again in donate. We are sending another transaction. We are donating 100 way this time. We can click in get balance. And now you can see that the balance is 102. And if we go to the Sepolia ITRE scan and we go to the contract, we can see all the interactions with the contract. First was the contract creation 30 minutes ago. Then 3 minutes ago, I donated. Oh, okay, got stuck. Okay, is there, so we have only 3 transactions so far. The first one was the contract creation 30 minutes ago. The second one was a donate of 1 way. The third one, 1 minute ago, was a donation of 1 way. And then if we refresh, we should have the donation of 100 way too. Yeah. And then 45 seconds ago, we have a new interaction of a donation of 100 way. I haven't withdrawn yet. I didn't create a function for withdraw, but it will be the same. Do you guys have any question so far with this? Now we are donating, and then if we don't withdraw, then it will never, the funds will get stuck in the contract. Here we can see the ETH balance. Oh, okay, it's slow there. Yeah, I think it will be just useful if I share the code. You can also go through that. And yeah, we will be this week. Okay, 102. This is the balance of the contract, 102 way. Yeah, so I don't know. We kind of need to leave this place soon, I guess. I will have some time to answer questions if you have any questions. And yeah, if you want, we will also go this week to JQuad and QA, Catholic University. Yeah, to build also a dApp. But yeah, I don't know if you guys have any question. I'm going to publish this in GitHub repo, in my Twitter as well, Santiago DevRel, so you can get the code. And yeah, you guys have any question? You can, yeah.
believe, and you explained it, you said data is stored in distributed, I mean, in
Yeah, these distributed nodes.
on decentralized networks.
Yeah.
And distributed nodes.
Yeah.
And then, okay, I believe Web3 is on trial still. It's not like complete. So is it going to overtake, not completely overtake Web2, but is it going to overtake it in being powerful? Or
That's a good question. I don't think it will overtake Web 2, but it will just offer different use cases and functionalities than Web 2, because in Web 2 you are not able to send kind of this value or send data in the same way as Web 3, that you can just send money like that. You only need internet to be able to send a transaction. So when I was doing all this Web3JS Africa tour and I was in Ghana or Nigeria, it was really good just to send cryptocurrency to someone, and then that someone can give me the cash there, or even to pay in crypto. That's why I think cryptocurrencies are the strongest use case of Web3. It's not everything, but it's the strongest use case, the currency part of it. Because you just need basically internet. If you have internet, you can access to this, and this contract will be there alive forever, something that in Web 2 will not happen, right? So it will have different use cases that I think the whole industry is trying to understand. What can we do in Web 3 that maybe Web 2 cannot do as good, right? But I don't think it will overtake Web 2. It will just add more functionalities, and we'll have kind of both things, because you need to be a Web 2 developer to build in Web 3. The only difference, to be honest, is that instead of having a database of, let's say, MongoDB, you're having a smart contract in the backend. That's the only difference that I see in an app.
So I don't know if I heard well. So in Web3, technology that it's like blockchain is one of it, and also
Smart contracts. Yeah, actually, you can use the same things, but instead of using the database, you will use the blockchain as a database. But you can also use HTML, CSS to make a website, and then instead of storing something in your database, you are going to call the smart contract, and the smart contract will store the data that you want. In this case, our smart contract is only storing owner, that is my address, but in other cases, your smart contract can store ages or names or addresses or whatever, and then you will call the smart contract to retrieve the data, the information. So it's the same. Web 2 and Web 3 is the same. The only difference is the database that you are using. I will call it like that. Instead of using JavaScript and MongoDB to interact with a database, you will interact with a smart contract. Yeah, thank you. Any other question? Okay, so then I think that's kind of everything for today.